Hello everyone, my name is Mr. Zabron Ernest. I teach mathematics. Welcome for the presentation of today. I will be revising 3 chapters of class 7. The first chapter is arithmetic expressions, and the second chapter is a peek beyond the point, and the third chapter is expressions using letter numbers. I'm going to revise these 3 chapters in form of questions, and these questions have been arranged in format of slides. All right, so without delay, let us get started. Now, slide number 1 is the first question, which says that a family travels by a car to different places. They cover 5 trips of 120 kilometers each, and 3 trips of 80 kilometers each, and 2 trips of 150 kilometers each, and 4 trips of 60 kilometers each. Here the question is, frame an expression for the total distance traveled and compute its value. So you can pause this video and take a screenshot of this question and perhaps try it in your own arrangement and in your own understanding. So without delay, let us get started. All right. So there are 2 questions here. The first question is to frame an expression for the total distance, and the second question is to compute the value of the expression. Okay, now, what you are going to do is to form expression for each trip. Now, the first trip is covering 5 trips for 120. So how will be the expression? So this is known as individual and separate expressions for each trip. So for 5 trips, each 120 kilometers, that means you do 120 into 5. 120 into 5. This is the first expression. And for 3 trips of 80 kilometers each, you do 80 into 3. So you do 80 into 3. And then for the second trip, for the third trip, which is a 150 kilometer, and 2 trips of 150 kilometers each. So you do 150 into 2, 150 into 2, and then you do 60 kilometers each, 4 trips of 60 kilometers each, you do 60 into 4. So that is 60 into 4. Now, the expression for the total distance. So expression for the total distance, expression for the total distance. What are we supposed to do? You take these individual expressions, then plus all of them. So we have 120 into 5 plus 80 into 3 plus 150 into 2 plus 60 into 4. So this is the expression for the total distance. Right. Now, how do we calculate the value? That will be the second question. Value. So you write here, value. 120 into 5. 120 into 5. 12 into 5, that is 60. This 0, add it here. Plus 80 into 3, do 80 into 3. 24, add 0 here. Plus 15 into 2, that is 30. Add this 0 here. 6 into 4, 24. Add 0 here. Now, you have to add 600 plus 240 plus 300 plus 240. And usually we will prefer arranging these numbers vertically. So you take 600 here, 240 here, 300, and then you do 240. What is the answer here? This is 0, that is 8. This is 8. this is 8, 11, 13. So the value here will be equal to 1380 kilometer, because they are talking about the total distance traveled, and it should be in a kilometer, right? So this is the expression. This is the expression for the total distance, and this one is the value of the total distance. All right. Now, second question. Second question is simplify and evaluate. Now, when you look at this expression here, this expression has too many brackets. So what we are going to do is to work out one bracket after the other. Okay? But you can see that the value of A here equals 6. So what we are going to do, we are going to rewrite this expression. When we reach here on A, we're going to replace A by 6. All right? So this will be open bracket 90 minus open bracket again 12 plus open bracket 8 minus 3, close that bracket, close another bracket, close the second bracket. Then into open bracket, open another one, 30 minus 25, close bracket, plus open bracket, 15 minus 10, close bracket, divide by. When we reach here on A, we're going to replace A by 6. So 6 minus 4, then we close bracket. Now, there are so many brackets here. So there is the way how to evaluate too many brackets. What do? We start evaluating the bracket which is inside the other. So here we do evaluate the bracket which is inside the other. So we have to start with the bracket which is inside the other. Now, look at this bracket here. This bracket here, which is opening here and closing here, it is inside of this bracket. So the bracket which is inside the other is the one which we start evaluating. Likewise, this bracket here and this bracket here, both of these brackets are inside this bracket here. So what we start doing, you evaluate the bracket which is inside the other, while the other remaining brackets should wait. Okay? So you're going to start with this bracket. You open it here. Then 90 minus, open this bracket, 12 plus. When you reach here, then you need to evaluate. 8 minus 3, that is 5. The moment you write 5, this bracket here is no more. Okay? So you're going to close the bracket here and close this one here. Then into open bracket. The moment you reach here, you have to evaluate this bracket. 30 minus 25 is 5. The moment you write 5, this bracket is no more. The moment you write 5, 30 minus 25, the answer is 5. This bracket has gone off. Then plus, then evaluate this bracket. 15 minus 10 also is 5. The moment you write 5, this bracket has gone off. Then you're going to close this bracket here. Then divide by 6 minus 4. Okay? Now, we still have another bracket here which is inside this bracket. So again we start, evaluate the bracket which is inside the other. So this bracket is inside this bracket. So this bracket is to weight 90 minus. The moment you reach here, you need to evaluate 12 plus 5, and this is 12 plus 5, that is 17. The moment you write 17, this bracket is no more, has gone off. So close the bracket here, then into 5 plus 5 divide by 6 minus 4. So you can see that before we had too many brackets. Now step by step has given us this step here, which now there is no bracket which is inside the other. So every bracket here is independent of the other. So now you can evaluate this bracket, evaluate this bracket, and evaluate this bracket. Okay? So 90 minus 17, 90 minus 17, this will be kind of 73, because that is 10, get 1, 8, 90. Then into 5 plus 5 is 10, divide by 6 minus 4 is 2. Okay? So now, when you reach here, you have to follow BODMAS. That division is to come first before multiplication. So this will be 73. Multiplication has to wait, and then you do 10 divided by 2, that is 5. And then lastly, you do 73 into 5, that is 15, carry 1, and this will be 35, 36. So the answer will be 365. Okay? So that's the way how we do. This is the way how we simplify these brackets, these too many brackets. Okay? I hope that is clear. So now you can try to pause this video and then take a screenshot of all this. Okay? Right? So this is the solution. These are the steps. And there we go. Okay? So the next slide is this question here. The weights of certain packets the weights of certain packets are recorded as follows. We have 2.5. We have 2.5, drop out the kg, 3.0, drop out the kg, 3.5. And we have the blanks here, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. Now the question is, determine the difference between consecutive terms and extend the sequence by 6 more terms. Okay? So here we have to find from 2.5 to 3.0, there is an increase of 0.5, meaning add 0.5. Also, we add 0.5. Also, we keep adding 0.5. So add 0.5, we're going to get 4. Add 0.5, we're going to get 4.5. And then keep adding 0.5. So this is 5, 5.5, then 6.0, we may say, and then 6.5. So this is 4.5, this is 5.0, and this is 4, or you can say 4.0. Okay? Either way. Right? So you can write here 4, then 4.5, then 5, then 5.5, then 6, then 6.5. So that's all. Now determining the difference. This difference, which you see here, this number, add 0.5, add 0.5, add 0.5, add 0.5. This difference is what we call the common difference. So in this case, the difference between two consecutive numbers is this number here. Add 0.5, add 0.5, add 0.5, add 0.5, add 0.5, add 0.5. That is what we call the difference between consecutive terms. In other words, we call it common difference. So the common difference here is add 0.5 or positive 0.5. So that is the common difference between consecutive terms. And extend the sequence by 6 more terms. The 6 more terms immediately after 3.5, because we know how the pattern extends. It goes by the rule 2.5 to 3.0 is add 0.5, add 0.5, add 0.5. So we keep adding 0.5 to infinity. Now, since they need only 6 more terms, you're going to write after 3.5 comes 4.0, 4.5, 5.0, 5.5, 6.0, 6.5. These are 1, 2, 3, 4, 5, 6 more terms. Okay? So I hope you can pause this video and take a screenshot of this question and the answer as well. All right. The next slide or the next question is talking about the daily rent for a bicycle. So the daily rent for a bicycle increases in the sequence. So we're given again a sequence, but it is talking about the daily rent for a bicycle. Now, this daily rent for a bicycle increases in the sequence of 5, 10, 15, 20, and so on. Now the question is, formulate the expression for the kth term of this sequence and calculate its value when k is 25. Okay? So we have to study this pattern. From 5 to 10 is add 5. From 10 to 15, again add 5. From 15 to 20, again add 5. So that means we keep looping by adding 5, adding 5, adding 5 to infinity. What does this mean? It means that if you are looking for the first term, which is 5, which is this number here, 5. If you are looking for the first term, which is this number here, 5, you're going to take this number, 5, into 1. 5 into 1 gives you 5. To find this number, which is the second number, or the second term, we take this number again, which is 5, into 2. 5 into 2 is 10. To find this number, which is the third number, we take this number into 3. So it will be 5 into 3, 15. To find this number, which is the fourth number or the fourth term, again, you take the same number into 5. So you can see that the pattern keeps on going, but it starts with 5 into 1, 5 into 2, 5 into 3, 5 into 4. So to find the kth term, that means you're going to keep the same 5 into k, and this is what we call the expression for the kth term. So we write it that kth term, or you can write it like this, kth term is 5 into k. And also, you can omit this multiplication sign and let it stay as 5k. The same thing. So you write 5k simply means 5 into k. Now, the next question. Can you calculate the value when k is 25? So you write here, for k equal to 25, the value will be 5 into k. But what is the value of k? We're going to replace k by 25. So 5 into 25. And then you calculate 5 into 25, you get 125. That is the value. So the expression for the kth term, is 5 into k. And the value of this sequence when k is 25, we're going to replace k by 25 and do 5 into 25, and the answer is 125. So you can pause this video, take a screenshot of the question and take the answer or the steps. Okay? I hope that is clear. The next slide is like the same concept only. A theater adds new seats in rows in the pattern 12, 24, 36, 48, and so on. Perfect. Now the question is, write the formula for the mth row. The first question, write the formula. In other words, write expression. How do we write the formula or the expression for the mth row? Well, we study the sequence. From 12 to 24, add 12. 24 to 36, add 12. 36 to 48, add 12. Keep adding 12, keep adding 12, keep adding 12 to infinity. Now, how do we get the expression for the mth row? You study from the first term, or you study from the first number. The first number here, the first number or the first term is 12. So that means you take 12 into 1. 12 into 1 is 12. To get the second number, you again take 12 into 2. That makes 24. To get the third number, or the third term, you take this 12 into 3. Makes 36. To get the fourth term, you again take 12 into 4. Now, look, to get the first number, 12 into 1. Second number, 12 into 2. Third number, 12 into 3. Fourth number, 12 into 4. Now, to get the mth number or mth term, you're gonna get 12 into m, and this is what we call the formula or the expression for the mth row. Now, here comes the next question. Find the number of seats in the m equals to 18th row. So that means for m equals to 18, how many seats are there? So number of seats will equal 12 into m. But what is your m? Your m is 18. So you're going to do 12 into 18. Now, how do we do 12 into 18? Well, 12 into 18, arrange vertically. That is 16, carry 1. That is 8 into 1, 8, add 1, 9. And this is 1 into 2, that is 2. 1 into 1 is 1. Then add these numbers. So you have 6 here, you have 11 here, then add 1, you carry 1 here, that is 2. So 6, 11, 2. So the answer will be 216 seats. 216 seats. Okay? So you can pause this video and try to take a screenshot of the question and then see the method and the final answer. All right? So the next slide. This question says, a rope measures 3.25 upon 100. Or you can say 3/2500. Another rope is 1/4500. And this one is 72/100. So this is 25/100, 45/100, 72/100. Now, what is the question? Find how much longer the longest rope is compared to the shortest rope. This is 3/2500. So the whole number here is 3. This is 72/100. So automatically, this is the shortest rope and this is the longest rope. Now, find how much longer the longest rope is compared to the shortest rope. Represent your answer first as a fraction and then as a decimal. That means you take the longest minus shortest. Now, the longest is 3/25 upon 100 minus the shortest is 72/100. Now, how do we move from here? We do 100 into 3. The answer you get, add 25. So 100 into 3 is 300. Add 25 is 325 upon 100 minus. This is already a fraction, so we're going to do 72 upon 100. Now, since denominators are the same, then you're going to put a line like so, and then write 100. And because this denominator and this denominator are the same, so what do? Copy paste this number and copy paste this number. 325 minus 72. You are done. And then you do 325 minus 72. That is 3. That is 212 minus 75. And then 2. So the answer is 253 upon 100. Right? Now, the question says, write the answer as a fraction as well as a decimal. So, we have this one here will be a section for fraction, and this one will be a section for a decimal. Now, fraction, we already have 253 upon 100. You can leave it like this, or you can keep it as a mixed number, like 253 upon 100. Both of these are the answers. As a decimal, 253 upon 100, because the denominator is 100, that means you're going to copy paste the 253, but this 253 will have 2 decimal places, meaning move a decimal point from right going left 2 steps, 1, 2, and the decimal point will stay there, and the answer becomes 2.53. So you can pause this video and then take a screenshot. Okay? So this is the question. And you can do numbering that we have done Roman 1. And what is remaining is Roman 2, which is finding the combining length of the 3 ropes. So Roman 1 was to find the difference between this number and this number. The second question, so you can do labeling. This is Roman 1, and this is Roman 2. Find the combined length of the 3 ropes. Combined length means total length. Find the total length of the 3 ropes. Now, how do we find the total length? You want to take this length plus this length plus this length. Meaning 325 by 100 plus 325 by 100 plus 1 plus 1, 45 by 100, and the last one will be 72 upon 100. Now, how do we move from here? Simple. Change this mixed number into improper fraction. You do 100 into 3. The answer you get, add 25. And likewise, you do the same thing. 100 into 1, add 45. So 100 into 3 is 300. Add 25 is 325 upon 100 plus 100 into 1 is 100. Add 45 is 145 upon 100. Then you do plus 72 upon 100. Then, again, the denominators are the same. Since denominators are the same, make a line, copy-paste the denominator, and also copy-paste all these numbers. 325 plus 145 plus 72. What is the answer? Arrange the numbers vertically. 325, 145, 72. 5 plus 5, 10, 12, carry 1. 2 plus 4, 6, 13, add 1, 14, carry 1. 3 plus 1, 4, add 1, 5. So the answer will be 542 upon 100. Now, if you go back to the question, it says, find the combined length of the 3 ropes. But it did not say leave the answer as a fraction as well as a decimal. For the sake of this video, I'm going to put the answer as a fraction as well as a decimal. But the question does not have that instruction. So for further study, I'm going to write this answer as a fraction as well as a decimal. So fraction here, decimal here. Now, for the case of fraction, we have 542 upon 100, which is already a fraction. What is missing is to simplify this fraction. Meaning, this number here is divisible by 2. Also, this number is divisible by 2. That is what it means by simplifying. Now, 542 divided by 2. That will be 27, 1. You can do it in any method you do, but 542 divided by 2, the answer will be 271. You can check it here quickly. This is 2, that is 14 carry 1, that is 4, 5. And 100 divided by 2, that is 50. Now, this will be the simplest form, meaning there is no any number that can divide 50 and 271. So you stop here. The moment you stop here, this is what we call the lowest term. Or, in other words, the simplest form. The simplest form. So when they ask you, can you write a fraction? Can you write this fraction in its lowest term or in its simplest form? You need to simplify this fraction. And when you simplify this fraction, you're going to end up getting 271 upon 50, of which you can write it as a mixed number. But you can even stop here. That represents a fraction. Now, this number, 542 upon 100, is a decimal. Remember, this is denominator 100. Denominator 100 will cause this number, 542, to have 2 decimal places, meaning move a decimal point from right to left 2 steps. 1, 2. And the answer becomes 5.42. That's all. So you can pause this video and then follow the steps and see how it works. All right? Now let me stop here. I will come for video part 2, which will be the continuations of the remaining questions. I think I'm left with 6 more slides, so I'll come in the second part of the video. Thank you very much for listening.